Let's determine the amplitude, period, and phase shift of this function, y equals 1/3 cosine of 4x minus pi. For the numbers that appear within this equation, I know the number here, the 1/3, is going to affect the amplitude. The number in front of the x is going to affect the period. And then somehow this minus pi is going to shift the graph, either left or right. So that's what we call the phase shift. So for the computation of the amplitude, it's going to be the number that is multiplied to the front of this function, which in this case is 1/3. Amplitude is always recorded as a positive number. If this happened to be -1/3, the answer would still be positive 1/3. Now in terms of the period, that is completely determined by the number that is in front of the x. This is the number that will either stretch or shrink your graph horizontally. The period of just cosine itself, cosine of x, is 2 pi. If you want the period of cosine of something like 4x, you'd have to take the period, which is 2 pi, and divide it by 4. Of course, if you enter this answer, it'll mark it as wrong because it's not simplified. I know 4 goes into the numerator, canceling that 2. So really, here the period is pi over 2. That came from 2 pi divided by 4, this thing. Okay, next is the phase shift. So while it's true this number is going to move the graph, actually I guess a couple of things. Because this is a negative, I know the graph isn't going to be shifted to the left, instead it's going to go to the right. In terms of transformations, anything that is affecting your x values, it'll have the opposite effect of what you would expect. So this minus actually moves the graph to the right. So that's why for phase shift, if you see a negative, I know it's really going to be a positive result here. So I don't have to enter in a positive sign, but just something to be careful about. The phase shift is determined by taking this number, which is pi, and dividing it by the number in front of the x, which is 4. So that is the phase shift of this function. Now if we put all of this together, I'm going to click here to enlarge this graph to hopefully graph the cosine function. Alright, so in terms of the options over here, here's the sine tool, but I want to use the cosine tool. So I'll click this, and you can click anywhere in the xy plane. And here's a standard cosine of x function. The period is 2 pi, the amplitude is 1. Let's enter in these new values. Starting with the amplitude, I'll go here first. It's 1/3. And if I click off to the side, okay, I see that this is a vertical shrink of my graph. Perfect. The period, which is 2 pi over, that's pi over 2. Okay, so this thing here. So I'm going to delete the 2 and just put divided by 2. Okay, so that's the period. So it's shorter, and we get more oscillations as we go from 0 to 2 pi. In fact, you get one period of this cosine function as we go from here to here, which is pi over 2. Now there's also this phase shift, and that's affecting your graph horizontally because it's changing the x values. So what I'm going to do is type in pi to get the symbol pi, the divided by symbol to put in a fraction, and I'll put 4 here. Okay, so that's going to move this graph pi over 4 to the right. So like this point's going to go here. And it did. In fact, all of the points moved pi over 4 to the right. So I can close this thing, and I'll save my graph. And here's what the function should look like. Just be careful, some of the questions also ask you to graph the original cosine function itself. We are not asked to do that here, so I have to go no further. I'll just check my answer. And great. That is everything for this problem.